Hello, everybody. Good to have you back. Welcome to another video on my channel. So today we will be looking at inverse functions and relations. I'm gonna go back, inverse, ha ha ha. No, I'm joking. Let's do my proper joke now. Which bear is the most condescending? A pan, duh. Okay. All right, so we're gonna get into inverse relations today. And these are, I guess, some sort of useful functions that they kind of cancel each other out in the real world. So that's the whole idea of an inverse. Now, we know that inverse relations or inverse functions or inverse operations already exist. We know the opposite of plus is minus. We know the opposite of times is divide. The opposite of an exponential is log. There's all these different opposites that kind of undo each other. And that's what we're going to be looking at in particular with functions, especially kind of how they look graphically. Now, just a common misconception that I will point out, it is not the same as a reciprocal. Some people think inverse and they go to the power of -1, but remember, sometimes we use that for a reciprocal function. That's the notation. So just be aware here, that's not what we're talking about. So let's start with what happens algebraically when we try to get an inverse function. Now, what happens is it's kind of like we do the opposite. So the easiest way to do it is I want you to think of every x and y, we're just going to swap. Okay. So what do? We swap the x's and the y's, they swap over. And then the reason that we rearrange to make y the subject again is because we like our functions in terms of y or our relations in terms of y. So y equals. What that actually just does, swapping the x's and the y's, it just changes your ordered coordinates. So for example, if x is 1 and y is 5, the inverse would be x is 5, y is 1. So they just swap over. Okay. Now let me show you really quick with a couple examples here. What happens algebraically? Well, let's look at this one. It's nice and easy. Every time I see a y, I'm going to replace it with x. Every time I see an x, I'm going to replace it with y. Okay. Now, again, I don't want to leave it like that. What I want to do is I want to keep rearranging on a +4 to the other side here. So I got x plus 4 left with 2y. And then just to clean it up here, I'll have y equals to x on 2 plus 4 divided by 2. In this case, it's just going to be 2. So that there, I mean, if you really want, you can rearrange to, y equals to half x plus 2. And that there would be your inverse of y equals 2x minus 4. Okay, let's try something with, powers. That's something a little bit more is going on here. So every time I see a y, I'm going to replace it with x. And then every time I see an x, I'm going to replace it with y. So you're going to get y squared here plus 6. And again, I don't want to leave my equation like this. I want to get y on its own. So again, let's go y squared equals to x minus 6, just moving the 6 over. And then y would become the square root, or in this case, plus minus the square root of x minus 6. All right, and then I guess to rearrange, I'll do the same thing. I like my y's on the left-hand side. A little bit pedantic about that, but that's fine. And that there would be my inverse of y equals x squared plus 6. Hopefully that's easy. Just a little bit of swapping the x's and y's and a little bit of rearranging to make y the subject. That's it. Okay, now that's kind of cool and easy to do algebraically. But what we need to do is we need to understand what happens graphically, because this is probably along the lines of what they'll ask a little bit more often. Okay, so now graphically, what happens is the inverse function is the original function reflected across the y equals x line. Okay, so if I was to draw it, this is what I mean. So that means basically every x value now becomes a y value, every y value becomes an x value. So it kind of does this reflection across the y equals x. So if I was to almost dot in y equals x would look like this. Right, so let's say that's y equals x. And so all I would do now is I'll do this in green. It's just going to look the exact opposite. So it's going to be reflected exactly. It's going to go 0. That's fine. But this time it's going to go underneath, back to here, Let's go continue on. So that there, that green line is what our inverse function would look like in that case. Something like that. And again, if we had a parabola, let's take a look. This one's going to be a little bit trickier because there's a little bit more going on, but I'm going to do my best to. There's your y equals x line. So we draw that in, and I need you to imagine that we're kind of flipping it over or reflecting it. So I'm just going to start with what I can see already. I can see that part there. That's fine. I can see that there's a little part over here that kind of jumps over. And for this part here, it's just going to go all the way kind of up this way. So you can kind of see that it just flips it on its side. And now we've got a sideways parabola, but hopefully you can see that there's some sort of reflection against that y equals x line. That's it. Now, what this also means, these are some implications here, and these are, I think it makes a little bit of logical sense if we stretch it. That means if we talk about domain, which is kind of like the, talks about the x values, right? Of the inverse is going to be the range, which is going to be the y values, the permissible x values and the permissible y values. It makes sense that the domain of the inverse is going to be the range of the original, and the range of the inverse is going to be the domain of the original. It's kind of like because they swap around. So for example, if I took a real quick look here, my domain for this nice, what do you call it? This domain here is going to be all real x, right? Because I have all values of x is possible. So that means the range for my other graph is going to be all real y. Yep. Same deal with if I look at my range for my black parabola, I can see here that x here, oh, whoops, not x, because range talks about y is greater than 0. But you can see here, for this one here, if I'm talking about my domain, it's actually x that has to be greater than 0. So you can kind of see how they interplay off each other. One, the inverse of the domain is going to be the range of the original, so on and so forth. Okay. I think I spent a little bit longer than I wanted to there, but let's move on. Okay. I also wrote a little bit of a note here because there is a difference between a function and a relation. A function means that it's one-to-one. In other words, it's going to pass this thing called the vertical line test. I can draw a vertical line and I'll only ever cut the graph once. That is a function. It's one-to-one. If, for example, I've got a circle or a sideways parabola and I draw a straight line and I cut it more than once, we deem that to be a relation. Okay, now I'll show what that looks like in a question. Let's put it all together. So let's consider x minus 1 squared plus y plus 2 squared equals to 4. Now, hopefully you recognize that this is a graph of a circle. Okay, but let's take a look at this question and let's tackle it. So find its inverse. Every time I see x, I'm going to write y. So it'd be y minus 1 squared. And every time I see y, I'm going to say x plus 2 squared, and then equals to 4. Nothing else changes, just the x's and the y's swap. Okay, now if they want us to sketch both the original and the inverse on an axis, let's do this here. I'm not going to make it super perfect, but it would be close enough. I know for this top one up here, I'll write this in red. I'm going to have a center of 1, -2 because of the x and the y. And I'm going to have a radius of 2 because it's r squared. And here, I can see here that my center this time is not going to be 1, -2, but it's actually the x value first, which is going to be -2. And then the y value, which is +1. And again, radius doesn't change. My radius for the inverse is still going to be 2. So if I take a look here, if I've got 1, -2, 1, -2, there's my first one. And then I'm going to have a circle of radius 2. I'm going to try my best here. I'll do this one in black. Something, look, that's probably the best I can do. Ah, look at that. That was pretty good. Okay, so this is 1, -2. That's that center there. And then the other one, we've got a center of -2, 1. So it's going to be -2 and 1. And it's going to have, again, a radius of 2. Again, I'm going to try my best. And not as good. Okay, now if I had done this correctly and beautifully, it's a little bit bigger, but you can see how it roughly is reflected against, be mature. It roughly reflects against that y equals x line that we talked about. Okay, find the domain and range of each. So I'll write orig, and then for the other one, I'll talk about the inverse. So all we have to do is find the domain and range of the original, right? So if we talk about the original, your domain, right? So this one here is your orig, and this one's the inverse. So with the original, we've got our domain. The x values are going to exist between -1 and 3. Yep, -1 and 3. So x would be between -1 and 3. Because I know it's got a radius of 2, so that means I know that it's going to go 2 across this way and 2 across that way. Okay, so from 1, add 2, you get to 3, and then take away 2, you get to -1. So that's why I got those values there. All right, and if I look at my range is, I'm looking at the y values, so it's going to be between 0 and -4. So that means y is going to be in between 0, or whoops, I should do -4 first because that's smaller, -4, but then 0. So that means inverse is just going to be the exact, almost the exact opposite. So for domain, for my inverse is, it's going to be, x is going to be in between -4 and 0, which we can kind of see is true, right? Between, if I did this properly, -4 and 0. And then your range is just going to be the opposite of the other one. So in this case, my y is going to be in between -1 and 3, which is exactly what we have there. So it makes sense, it holds. Last thing here, note whether either is a relation or a function. If I went to here and I drew a straight line anywhere, I would cut the line more than once. All right, I would cut the graph at 2 points. I can see I'd cut the graph at least there twice and at least there twice. There's places where that happens. So these ones here are a relation. So right here, both are relations, not functions. Hope that helps. And I'll catch you on another video that should help. Any questions, leave them below. Like and subscribe. Make me famous. All right. I'll catch you guys later. Bye-bye.